Celsius to Fahrenheit is C into 9 upon 5 plus 32.
Very good. Plus 32, that is the
32.
formula which we need to be using. Okay. And then we had like other formulas also, like if you were to directly convert from, let's say, Fahrenheit to Kelvin. Okay. Then what is the formula we will be using then? Yeah. What formula do
So,
we use then? First, we will be converting Fahrenheit into Celsius, and then we will add 273 to it, right?
yes,
That is
sir.
the formula which we will be using. Okay. Okay, then. Now let's continue. Okay, before we move ahead, can you name some of the properties of the mercury metal and why it is used in the thermometers? For what property it is used in thermometers? Yes.
So the mercury is used for the marking of the temperature in clinical thermometer.
Okay, that is correct. But for what property? What is the property of the mercury because of which we are using it in thermometers?
It doesn't stick to glass.
Hmm. Okay, that is
Mer-
another property. But what is the main property? The main property for which it is being used. Yes.
it is used for reading the temperature.
I'm talking about property. Okay. So when we talk about property of mercury, that is Hg, symbol of mercury is Hg. So mercury, the property of mercury is basically what? It expands on heating now. It expands on heating. Okay.
Yes, sir.
And another property is that it does not stick on to the glass. Okay. So it is non-sticky to the glass. So due to the, basically because of these two main properties, we are using them in the thermometers, right? Okay.
Yes, sir.
Okay, fast forward to what we were discussing. Hmm. So we did talk about conversion. Now let's continue about the transfer of heat from one medium to another, right? Like how heat will be transferring from one medium to another, how it will be transferring from a solid to a liquid, from a solid body to another solid body. So all these things we are going to cover now, right? Okay. Look, basically, whenever the molecules, okay, whenever the molecules of any substance are heated, so upon being heated, they are energized now. They are energized. Getting it, guys?
So,
Okay, is Abdul back in the class? Yes, Abdul.
Yes, sir.
Yeah. So upon being heated, the molecules of, whether the molecules of solid, liquid, or gas, they are being energized. Getting it now? So they will be in continuous motion now because they are having energy. So the molecules will now continue to move from here to there, right? And they will basically try to transfer their heat to other molecules. You guys getting what I'm trying to say? They will not be stable now. They will try to share their energy with the molecules of other medium. All right. So that is how the transfer of heat basically takes place, right? So consider a medium, for example, take a solid block A and take a solid block B, right? So when I am heating a solid block A, thereby what happens? The molecules are now gaining the energy, right? So due to gaining the energy, now the molecules of the solid A will start to vibrate. It will start to move here and there, right? Although the movement of these solid molecules will be not that much because it's a solid medium. Okay, now?
yes, sir.
Okay. So instead of changing the shape of this solid, what this solid material will do now? It will try to transfer its energy to another solid block B, for example. Okay. So that is how the transfer of heat takes place. So basically, the molecules of the medium, they want to be in a state of stableness. Okay, they don't want to move here, and then they want a stable state. Hope you guys are able to relate what I'm trying to say.
Yes,
So
sir.
thereby, when they will have transferred their energy to another medium, then they will come back to their initial state of rest. Okay. So always the transfer of heat will take place from a hotter body to a colder body, right? So heat always flows from a region of high temperature to a region of lower temperature. That can also be said. A body having more heat means it is having a higher temperature. So heat will flow from a region having high temperature to a lower temperature till both attains the same temperature, right? So suppose two bodies here are in contact with each other. Body number A and body number B are in contact with each other, and body number A is hotter. So the question here comes, till when the transfer of heat will take place from body A to body B? Yeah. The question is that till when the transfer of heat will take place from body A to body B? The thing is that when both the bodies have acquired the same temperature. Okay. When both the
Okay.
bodies A and B would have acquired the same temperature, then the flow of heat will stop. That is
Okay,
clear?
sir. Yes, sir.
Okay. And then, depending upon the different types of medium, the manner in which heat will be transferring will be different. Okay. For example, if you were to see the transfer of heat in a solid medium, so there the transfer of heat will take place by the process of conduction. Okay. And if you were to consider mediums which are liquid in state or which are gases in state, so thereby heat will transfer via the convection process. Have a look at this example. Okay, that's a classic example in where we get to see the examples of all the three modes of transfer of heat. All conduction, convection, and radiation can be observed in here. Okay, now,
Yes, sir.
yes. Hmm. So look where, look over here. So if you were to see this handle of this utensil over here, it is usually hot because the heat is being transferred to it as it is a metal, and here it's a solid medium. The flow of heat is taking place in a solid medium, thereby it will be conduction. We will be discussing each of them in detail. I am just giving you a glimpse of what the thing is basically here. Then the water that is getting warm due to the heat, it will be due to the process of convection, right? And then this some amount of heat will be radiated back from this flame and from this hot water also. Some of the heat will be radiated into the atmosphere. Okay, so radiation basically leads to loss of heat, right? So these are the three modes of transfer of heat which we will be discussing. Okay, so first let's talk about conduction, right? So from the image, what do you guys understand from this image over here? Yes, what is basically happening in here? Yes.
The heat is transferring
Hmm. Heat is transferring here.
to a
Okay,
metal stripe.
through this metal stripe. So here, what do we observe basically? That this region of metal strip is becoming hotter and hotter. Okay, since it is exposed to the candle flame. So thereby, if I were to have a close look here, have a close look here. Okay, this metal strip must be made up of atoms, right now. You guys know what are atoms? Simply the fundamental and structural unit present in a element,
Yes, sir.
the tiniest particle of any element, that is called basically atoms. Look, so there would be so many atoms present in it, and since it is a solid, the atoms are close to each other. Right now, the atoms are close to each other. Right, they are in close contact to each other. Had it been a like liquid, okay, in the liquid, the atoms are farther away from each other, and in gaseous state, the atoms are farthest away from each other. Getting it now, guys? Okay. So since all the atoms of this metal strip are in close contact to each other, thereby heat will transfer from one atom to another. Okay, heat will transfer from one atom to another, and thereby heat will transfer from this hotter end of the metal strip to the colder strip of the metal strip here. Hope it is getting clear. Yeah.
Yes, sir.
Yes,
So
sir.
that is how heat basically transfers in the conduction, right? Okay. So conduction is nothing but the transfer of heat from the hotter part to the colder part of an object due to collision of its particles without actual movement of the particles from the position. So two important things needs to be noted over here, that are there actual movement of atoms here? Are the atoms are actually moving from this hotter end to the colder end? Yes.
Yes.
Look over here. Are the atoms from this part of the metal strip have moved towards this part of the atom strip, or is it like they are colliding with each other, and due to collision the transfer of heat is taking place?
Transfer of heat is taking place.
Hmm. Yeah, transfer of heat is obviously taking place over here, but the manner in which it is taking place, it is said, and in fact it is true, that basically the atoms are colliding with each other. They collide with each other. Why would they collide with each other? Because of the heat, they now start vibrating. Okay, so thereby they collide into each other, and due to continuous collision, the transfer of heat takes place from one atom to another. Okay, so the atoms will remain wherever it is. Okay, it's not like this atom transfers to this side. No, the atom will remain over here, but all the atoms will be colliding with each other. Thereby, heat will transfer from one atom to the another atom. Is it clear? Yes.
So,
Yes, sir.
Okay. So that is simply about conduction, and we define it as follows. Okay. So it is the movement of heat from the hotter part of any object to the colder part of that object, right? And conduction, for conduction to take place, um the two bodies shall always be in contact with each other. Okay, the two bodies has to be in contact with each other, right? So remember that point also. Okay, and where does this mode of transfer of heat takes place? It will especially take place in solids and between two solid substance, within a solid substance or between two solid substance.
Sir.
Hmm. Yes, Abdul. Yeah. Yes, Abdul, go on. Yes, Abdul, you were saying something. Hello. Yeah, Tehsin, am I audible?
yes, sir, you're audible.
Okay. Okay. And then we get to see like there are different materials around us, right? If you were to touch a piece, a plastic object, and touch a object made up of metal, right? Both of them will have different temperatures, right now. Okay. So if I were to place a room heater in the room, place a room heater in the room, and then if I were to touch different objects which are made up of different materials, each will be having different temperatures, right? Because different substances have different properties, and some of them allows the heat to pass through them, while some of them does not allows the heat to pass through them easily. That's how we have classified substances as good and bad conductors of heat. Okay.
Yes, sir.
So any solid material that you will observe, whether it's a plastic object or whether it is a metal object, right? So they have different rate of conduction. Out of the plastic or metal, which will conduct heat more? Yes.
Sir, uh, this thing is cancelled, the conduction.
Yes.
For us, it's cancelled.
Okay.
For us, it's only till laboratory thermometer.
Okay. Okay. So certain part of the syllabus has been omitted for you.
Yes, but I
Okay.
still learn. It's okay.
Okay. Has Shivkami joined? Actually, I haven't joined from my computer today, so I couldn't see who has joined and who's left the class. Is Shivkami present in the class today? I guess not. Yeah, Abdul. Is that thing clear? Is the discussion so far clear to you?
Yes, sir.
Hmm. No. So as I say, rate of conduction will be different in different solids, right? So materials that will be conducting heat easily, they will be called as conductors. Usually all the metals that we get to see, they are good conductors of heat. Okay, but then also there will be some exceptions also, right? Which are not good conductors of heat. Talking about some of the metals that are good conductors of heat, they are like iron, copper, aluminum, etc. These are good conductors of heat. And then there are materials that does not allows the conduction of heat through it very easily. Conduction basically here means to allow the passage of heat through it, to allow the heat to pass through it. So you have examples of objects like wood, cotton, clay, rubber, these, and air and water. These are all insulators of heat. Now one question must arise, like, sir, wood actually burns now. Wood burns now, right? So
Yes,
wood burns.
they use wood for the fire, for heating themselves.
Exactly. We use wood in furnaces, in industries, okay, in household also wood is used to burn fire. But the thing here is that why is it that wood has been put under the category of insulator and not conductor? Yeah. Any idea why we have done that? Look, the thing is that when we heat a metal rod, when you heat a piece of metal rod, then suppose you are
Sir, I
heating
think I
this in.
know. Sir,
Yeah.
I think I know.
Yeah.
In
Answer
the
this.
if we take a metal stick
Hmm.
and one metal, yeah, if we take a metal stick, it will transfer heat to the another object, but with the wood, it won't transfer heat to the another object.
Exactly, exactly. If you were to take a metal rod, heat one of its end, the another end will also become hotter. But if you were to heat a burn a wood, so then the end which you are burning, that will only burn while the other part of the wood does not become hot. That is why we have considered it to be a insulator and not a conductor, right? And then you have materials like wool, feather, or fur. They also act as insulators because air is trapped inside their fibers, right? So the reason why we wear woolen clothes in the winter is for the reason that if you were to look at the winter clothes, they are having very fine fibers, right? And actually, the fibers might actually look like this, and in them there are tiny pores. See, these are the tiny pores in them, air pores. So basically what happens, these air pores will trap the air, it will trap air, right? And we know that air is a bad conductor of heat. Okay, air is a Bad conductor. Always remember that air is a bad conductor of heat, not a good conductor. So thereby what will happen? Suppose this is the body of any person, right? And heat actually is emitted by our body. Right now, our body is also having temperature of its own around 37 degrees Celsius. So heat is coming out from our body also. Okay. So usually in summer season, we wear light colored clothes and light clothes we wear right now. So thereby we allow the heat to pass from our body easily so that our body has a balanced temperature. Getting it now? But in the winter season, we don't want the heat to be lost from our body. Getting it now? Tehseen Abdul.
Yes,
So
sir.
for that purpose, we wear sweaters. So sweaters will do what? Sweaters have got very thin fibers in them, and they are air pores present in them. So, and that air pore will trap the air. So what will basically happen? Basically, there's a this heat has got no way to be released back into the environment because it is being trapped into the air pores present in the sweaters. Thereby, it keeps our body warm. You guys are getting it or not?
Yes, sir.
Oh, okay, that's a simple thing. Hope it is clear. Hmm. Then look at some of the examples of good conductors and bad conductors. Which of the two image represents a insulator?
The word is styrofoam and plastic.
Very good. So these are the examples of insulators, while the first one is example of conductors. Okay. Now moving on, we have got some of the daily life application of the conduction, right? So what are some of the applications of conductions we basically have? If you were to look at the pans that are used for cooking, right? So they will be basically made of metals such as steels, copper, or aluminum, since they are good conductors. While the plastic of these cans, while the handles of these cans will be basically made up of plastics, right? Had the body uh, of the utensil been made up of metal also, then the person will burn his hand, right now. So thereby, either we put a wooden handle over it, or either we use a plastic handle. All
Sir,
right now,
plastic handle.
right? Either plastic handle or either wooden handle is used in order to avoid burn from the utensil.
So that's why, sir, all
Hmm.
the pans and boilers and stuff are
Hmm.
made of metal and stuff, because then they can transfer heat and cook.
Exactly. That is the exact reason why the body is made up of metal so that heat can be transferred to the food and the food is cooked because of that heat. Okay, it is for that reason only. And the handle, we don't want to touch the hot part of the body or of the utensil. Thereby, handle is made up of wood, either a wood is placed over the handle because wood is a bad conductor, or either a plastic is used. Okay, now. Okay. And then plastics are also of different types, right? The one that is used as a handle is the one that does not melt when it is exposed to heat. Okay. Like plastics,
Yes,
if you
sir.
were to see certain plastics, they melt upon heating, while there are plastics that do not melt easily. They will be broken down into pieces, but it will not melt. So that type of plastic is used here.
Sir, glass transfers heat.
Glass. Oh, glass is also a bad conductor of heat. It transfers heat, but not that good conductor of heat. Okay, but we have put that in the category of a conductor actually. Okay, so yeah, a glass pretty much transfers heat. Okay, then clothes that are made up of fur, as we discussed moments ago, it will trap air inside them, and this trapped air acts as an insulator, so thereby it prevents the escape of heat from our body and hence keeps us warm in the winter season. Okay, all right. Now have a look at some of the examples, at some of the substances here, and say which one is an insulator here. Yes, the question is to both of you.
What?
Look at this question, read the question.
Which of the following is the insulator?
Yes, which one is an insulator over here?
B. Air.
Obviously air, right? While graphite used in pencil, or the aluminum rod or copper rod, these are all examples of conductors. Okay, next question. Yeah, Abdul, you also read the question.
Okay, sir. The process by
I can't hear him.
Abdul, we can't hear you.
now, sir, sound is coming.
Yeah, you're audible now.
Yes, sir. The process by which heat flows from the hotter end to colder end of an object is called dash.
Yes.
Sir, I
What
think
do
it's
we call them? That is
conduction.
conduction. Very good. Very good. Okay. Yeah, stainless steel pans are usually provided with copper bottom. The reason for this could be that. What do you think? What do you guys think? Yeah, Tahseen.
Sir,
Hmm.
This copper is a better conductor of heat than the stainless steel.
Exactly. Okay, now. So copper is a better conductor of heat than the stainless steel. That is the reason we use it as a base for stainless steel pans, right? Okay. Now you get to see now, like you have clothes of different colors, right? We have clothes of different colors. Okay.
Yes,
So
sir.
in summer we will be wearing clothes of light color, while in winters we wear clothes that are having a dark color. The reason for this is that dark colors are good absorbers of heat, right? While the light colors are good reflectors of heat. So that is the reason why we wear dark clothes in winter and light clothes in summer. Okay, so answer this question. Hmm. Yeah. Yes.
Summer.
Summer
Sir,
season, obviously. Okay. And the flow of heat by conduction will be generally observed in what? Will it be observed in solid, liquid, or gas? Or all the three options are correct here.
three options are correct, sir.
I'm asking now. I'm asking, are all three options correct here?
Okay, sir.
Yes.
Sir, I
What do you
know.
guys think? Yeah, you can also answer. Both of you can
Sir,
answer.
actually, yes.
All of these.
Mm-hmm. All
No,
of
no, no.
these.
Solids and liquids, but gases can't.
You guys need to. Abdul, you're also saying the same thing?
No, 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 sir. Solid.
Solids only, no? That's in all the examples we had so far. Okay. All the examples we had so far, and in our discussion also, we consider examples of solid metals only. And conduction will only be occurring within a solid object or between two solid objects, right? So conduction is applicable only for solids. Always remember this. Okay, now?
Yes, sir.
Yes, sir.
Okay. Right. Okay. Now, after conduction, we have got convection currents, right? Okay. So you guys must have seen, like, what do you observe when we go to coastal region? You guys know what is a coastal area, no? What does a coastal area mean? Yes,
So
right now. The area where land touches the ocean, right now. So that is basically the coastal areas. So what do we observe in the coastal areas? That gentle breezes moves from the seaside to the land side, right now. Okay. So do you guys know that occurs due to the process of what? What do we call that process? Like there also transfer of heat will be taking place. Okay. And that and there we understand the next concept of transfer of heat, that is simply convection. Okay. So in convection, basically what happens? There is transfer of molecules of the medium due to uneven heating between the two areas or two surfaces. Okay. So in the case of convection, what was happening? Basically, convection is the mode of transfer of heat from the hotter part of a fluid. Okay. We consider any fluid. Fluids are basically what? Liquid and gases. We call them as fluids, right? So in the case of
yes,
convection,
sir.
there will be transfer of heat from the hotter part of a fluid to the colder part of the fluid. Consider the example of this um, water being boiled in this kettle. So what do we observe over here? Look over here. Before we begin this discussion, few things you guys need to be aware of. Like first thing, yeah, first thing you guys need to note over here is that warmer particles are less denser. Okay, so thereby they rise up. Thereby they will rise up. All right. Then second concept you guys need to take care of here, that cooler particles are heavier and more denser. Thereby they fall back. Now come to this kettle. Look at this kettle over here. What is happening? The molecules of the water which are at the bottom of this kettle, they are in close contact to the source of heat, right? Tahsin, right, Abdul? So
Right, sir.
thereby they will be
Yes, sir. Yes.
warming up now. They will be warming up now. So due to being warmed up, now they will move upward, right? Why they will move upward? Because warmer particles are less denser. They are less heavier, right? So anything that is warm and having less weight, being lesser, um, having a less density, they will start to rise up. Now, as soon as the molecules of the water rise up, they are again now here they are far away from the heat. When the molecules have traveled to the surface, so they are not in contact with heat anymore. So thereby they again becomes cooled. They will again become cool, and then they will, because we know that colder particles are heavier and more denser, and we know they fall back. So they will start falling back to the base now. Now, as soon as they fall back to the base, then again they become hotter, and we know hotter particles are lesser denser and they rise up. So they again rise up, right now. So look over here. The heat is being transferred from this hotter part. The base is the hotter part, right now.
Yes.
The fluid, that this water that is present in the base, they are hotter, right? So in this fluid, the heat is being transferred from this hotter part towards the colder part, right? So this is the manner in which water basically boils, water basically heats. I hope it is clear.
Yes, sir. It's clear.
It is clear now, right? So that is simply convection, that it is the transfer of heat by the movement of particles, right? Now, if I were to compare convection with conduction, what were the differences we observed between the two? Yeah, who would like to explain this one? Anyone can explain this. Yeah.
Sorry, sir.
What is the difference between convection and conduction?
Sir, in conduction, there is a transfer of heat between a solid and a solid. And for example, a copper and a metal, stainless steel.
Okay.
And
In
in
solid,
conve-
continue,
and in
continue.
convection, it's the transfer of heat by the movement of particles.
Hmm.
And it's only for liquid and gases, while for conduction, it's in only solid form.
Right.
And sir,
Yeah, Abdul.
conditions for the conduction of heat are one body in contact with each other.
Hmm. Right. The body has to be in contact with each other. Okay. Here also, the whole medium is exposed to heat also, right? And here actually the transfer of heat is taking place due to the actual movement of particles. Thereby, when water boils, the water is actually in movement right now. So if you to talk about differences, it mainly occurs in liquids and gases only, while it occurs in solids only. And um, here in the case of conduction, there is no movement of molecules, while there is movement of molecules in this. Okay. Now you guys tell me, like, in order to heat a solid, if you were to heat a solid or if you were to heat a liquid, which will become warmer quickly? In
The
conduction,
liquid.
Solid
hmm,
and
my question is that which medium? Question is liquid
medium.
or solid will be heated up more quickly. Okay, when you
Sir,
answer it,
it's
come up
liquid.
with the answer also. Come up with the explanation also.
Okay.
Okay.
Okay, sir. And sir, what is this one? Okay, heat it.
Sir, can I answer?
Yeah.
Attempt.
Mhm.
My explanation is that a liquid will be more warmer because the cool molecules in the cool water will transfer quickly than the solid ones, because this solid ones take more time to transfer as it is solid to solid.
Okay. Yeah, Abdul.
Yes,
Yes,
sir.
Abdul.
Give me feedback, sir.
Okay. Look here. Look, what is happening now? In the case of conduction, first we need to know about, like, when we have examples of a solid and a liquid material, like, you need to know about the composition, right? The composition and the way in which the atoms are arranged in a solid and in a liquid are different. In a solid, the atoms are closer to each other, right? While in a liquid, atoms are not that much closer to each other. They are at some distance from each other. Okay. So look over here. Since the atoms in a solid are in close contact to each other, thereby the transfer of heat will take place quicker. Right now, because the atoms are in close contact with each other, thereby heat will take the transfer of heat will be more quicker. While in the case of liquid, which conducts heat by the process of convection, the atoms are not that much closer to each other. They are at somewhat distance from each other. Right now, So thereby it will take more time than a solid to become hot. Getting it, Tehseen and Abdul?
Yes, sir.
Sir, solid takes more
Hmm.
time.
No, liquids take up more time. Okay. And then like there are different other factors also we have to consider right now. If you were to have a solid mass, right, consider example of paper. Okay. And consider example of water. Okay. Take both of them in equal quantity. For example, if you were to take 100 grams of paper, take around 100 gram of water also, like 90 or 100 ml of water, you should also take that. Okay. So there what we will be observing here, that the manner in which you will be burning paper and the manner in which you will be heating the water, it might be different now, right? While the paper is in direct contact with the source of heat, while you cannot put the water in direct contact with the source of heat. Okay. On if you were to boil it in a utensil, then you will have to provide it heat in that case. So you have put it in the utensil, right? So while the paper you have to distribute into several pieces, you have to separate them and then heat them. So obviously, in whatever scenario you take, basically paper will burn more faster, right? Why it is burning more faster? Because there is transfer of heat taking place quickly from one end of the paper to the another end. But in the case of water, it needs to be heated up to a certain level so that the molecules actually starts to move. It needs to be heated up to 100 degrees Celsius so that each and every part of the fluid attains the same temperature, right? So like if you were to warm the water, okay, like if you were to warm the water for only like 1 minute, so what you might observe like the water in the base might be warmer, but the water in the water close to the surface will not be that much warmer. So uneven warming will take place there. Hope you guys are able to relate what I'm trying to say.
Yes, sir.
Yes, sir.
Okay. All right. Now, apart from so far in the case of convection, we have only been talking about liquids only. Moments later, we will come to gases also. Okay. And we will take daily life examples also, like what are the applications of convection current. Okay. So convection current, how does it take place? As we discussed moments ago, like when a liquid or a gas is heated, it will basically expand. So as a result, it becomes lighter and moves upward. As we saw that the warm molecules of water became lighter and then it started to move upwards. And then when again it cools down, it rushes back to the bottom, right? If you were to consider examples of uh, of gaseous medium where convection takes place. So what do we observe in that case? Look over here. During the daytime, what will happen? The property of land, we know that land heats up faster and also cools down faster, right? While the case with the water is that water heats up slowly and cools down slowly. Okay. Also keep in mind the two concepts, that warmer particles move upwards. It will move upwards, all right, while the heavier particles will move to a place where it is warmer. Note these two things. Okay, keep these two things in your mind. Okay, shall we begin with this convection current, how it gives rise to breeze in the coastal areas that we observe? Huh?
Sir, can you give us time to write?
Okay, yeah, write this down. Take your time and write this down.
And sir,
Yeah.
can I say something related to this one? Warmer particles move upwards.
Yeah, sure. Yeah, sure.
Yes, sir. Sir, as air is heated, the particles gain heat energy, allowing them to move faster and further apart.
Right. That is correct. Okay. As they gain heat, they start to move more
For
quickly in random
yes,
directions,
sir.
right now. So they basically gain kinetic energy, and thereby they start to travel from one place to another, right?
Yes, sir.
Okay. So although we know air is a poor conductor, no, air is a very bad conductor of heat. So
Yes,
air will basically transfer the heat from its hotter parts to the colder parts, right?
yes, sir.
Air also does not want to hold the heat, right? It
Yes,
basically will quickly try to transfer heat from the hotter part towards the colder parts,
sir.
right? So the convection currents that we actually see in the coastal areas, the breeze that the cold breeze or the warm breeze that we see in the coastal areas, it is actually due to the convection currents. Okay, you guys do tell me when you are done. Okay, now
Sir, I will write this one.
you guys can either write it, okay, or do one thing now. As we are discussing topics in the class, do
Yes, sir.
note down the important points. Okay, either note down the keywords, right? And no need to write the full definition because that will take a time. That will take too much time.
Sir,
Okay.
now just take screenshot after I will do it. Okay, my sir.
But make sure that you actually do it. Okay, but make sure that you actually take down the notes after the class. Okay, Tessin, you can also do one thing that although it's better to take the notes parallelly, like as we are having discussion, side by side, you can note down the things also. But then again, like in order to save time, you can just note down the important keywords. Okay.
Sir, I will write it down. Okay.
Okay. Okay. Okay. Keep noting it down while I'm saying the important points also. Right now. So while I will be discussing also, you guys can keep writing down. Okay. So during the day, what do we observe basically? The land will heat up more than the water, right now. The land heats up more than water. You guys must have observed that. Huh? If you ever happen to visit the coastal areas or the breeze or the beaches, then you will get to see the sands are warmer than the water. Obviously, because the property we know that land heats up faster, but then during the night time, land will also cool down very faster, right? So
Sir,
during the
can
day,
you read the 2 points?
yeah. So the first point, this one, the one in the blue color,
Both of them, yes.
warmer particles move upwards. Then the next point is heavier particles will move to a place where it is warmer. Okay, now. Or you can also put a bracket over here and write colder particles also. Okay. Okay, back to our discussion. What I was trying to say over here, that look here. That is the land and that is the water body over here. So during the daytime, what will happen? The air over the land will become warmer and it will start to rise up right now, because we know that warmer particles of the air are lighter and they will move upward. So because now the air particles are now moving upwards, so there will be a vacuum created over here, right? There will be an empty spaces created over here, no? Right, Tehsin Abdul? You guys are getting it now. So thereby what will happen? The
Yes,
warm, the colder particles of air that are above the ocean that will rush to take the empty space created over here. They will start to rush over here. They will rush towards this. So that's why we get to see like cold winds are blowing from the oceans towards the land during the daytime, right? And then again, as soon as the warm air molecules travel towards the land, so since land is more warmer, so thereby those air molecules that were coming from the ocean side, they will also become warmer and they will also start to rise up, right?
yes,
So this leads to a continuous cycle of movement of air from the ocean towards the land side. Right now, that is land, that is ocean. So there is continuous movement of air molecules from the ocean side towards the land side. Yes, Tahsin, getting it, Abdul?
yes, sir.
Yes,
Right now.
sir, can you explain that a little short once again because I was writing also.
Okay, sure. Okay. In the daytime, basically what happens, the air molecules over the land, they will be heated up because we know that land heats up faster. So the air that is above the land, they will also become warmer and then they will tend to rise up because we know when they are heated, they become lighter and they will start to rise up. So there will be an empty space created over here because the air molecules are now rising up from the land side now. So an empty space is created over here, right?
Yes, sir.
But there can't be an empty space over here, right? So that space will be taken up by the air molecules that are coming from the ocean side. So the air molecules coming from the ocean side will take up that empty space, right? So this process will continue throughout the day. This process will continue throughout the day. So the air
Yes,
molecules will be traveling from the ocean towards the land side and then will again start to rise up because the land is hotter over here. So that has been called as land breeze. And then just opposite happens during the night time. So during the
yes,
night time, what happens? As we guys know that land heats up faster, but it also cools down faster. So during the
yes.
night time, what happens? Land is colder.
Folder.
So air above the land is colder now, right,
Yes,
Tehsin?
Yes,
While
sir, right.
water heats up slowly and cools down also slowly. So water, since it will cool down slowly, so it is still warmer during the night time also. So here air is warmer, right? So warmer air, as we all know that warmer air will rise up now, right? So there will be an empty space created over here. That empty space will be taken up by the air that is present over the land, and the air that is present over the land will be moving towards this ocean side in order to take up the empty space created by the rising air. Hope that is clear. So that is simply the concept of sea breeze then, right now. Okay.
yes, sir.
So that
Yes,
is
sir.
basically what happens in the land breeze and the